Introduce to you Vyacheslav Stefanovsky with his lecture about REST API Antipatterns.
One, two, three. Hello. So, my name is Vyacheslav Stefanovsky. I will be talking about REST API Antipatterns. I'm head of development for Sourcecom Macedonia. I've been coding professionally for quite some time. I love programming, love programmers. My personal professional motto is building better programs and building better programmers. And this presentation is in that way because I've been kind of building APIs for a while now. My personal favorite in the development stack overall is usually the front part of the backend and also the back part of the front end, which means that it's focused on the communication between the server and the client, or as people call it, the REST API. So, what I will be talking about? I will be talking a bit about what a REST API is. Why do we need it? What is the need to have REST APIs at all? Then I will go into a bit of a discussion about anti-patterns, what anti-patterns are and what they are not. We will talk about REST API design a bit, about REST API design errors specifically, how we can get things wrong in REST APIs, and then I will discuss a bit about specifically some anti-patterns that I've seen done, and to be honest, that I've done myself in quite a few projects. So, let's get started on that. Well, you all know that REST API stands for Representational State Transfer. If it's clear to you what representational state transfer is, then great, because it's not clear to me. It's just a backronym, so we can have a cool name for this thing that we actually use. I mean, there is like a zillion names that are better. Anyway, that's a specific architectural style for networking applications in general. What's characteristic about it is that it uses the already defined HTTP methods for its applications. It uses get, put, push, delete, and so on and so forth. So, by design, it should be stateless. Each request should contain all the necessary information to fulfill that request. We have URLs, URIs, whatever you want to call them, that identify resources. And the data that is exchanged is typically in some format that is in, I would say, over 99% of the cases will be JSON or alternatively XML. Who here has used an REST API? Yeah, of course, everybody. So, how do we use them and why do we use them for? Well, more and more they are used for communication between the backend and the front end. And the major thing that REST APIs should provide is that we can build the backend in such a way that it's stateless. It doesn't know anything about the client that it's serving. And on the front end, what we get the benefit of is that our front end it's gonna be stateful, because don't forget, we need state. We want state. Nobody wants stateless applications. Everybody wants stateful application because it makes sense. When I'm going to Facebook, I want to see things that are relevant to me. When I click on something, I want that application to remember that I clicked on something. But what we can get on the front end is backend agnosticism. That the front end doesn't really care how the backend is built. Whether the backend is a single service or a whole cluster, or let the backend engineers play their own game, we can just use whatever it is. So we don't need to know how the backend server is built. We just say, we have an API, we'll just use it. It also enables us to have a lot of third-party integrations, because there's nothing that stops us from one company just building a server and another company just building a client. So we can also use third-party APIs, APIs that are not developed for us, and we can have a product, so to say, that all it does is basically aggregates different APIs from different providers. That's also a thing that we can do. And so in essence, the REST API becomes a bridge between the UI as the front end and the server with all its underlying logic, databases, data stores, and everything. Yeah, let's switch it up a bit. Let's define what an anti-pattern is, because we have two things in the title of this talk. It's REST API anti-patterns. Well, an anti-pattern, everybody knows what software patterns are, design patterns, things like that? Sure. Well, that's a response, a solution for a recurring problem that we have. So we have a problem more than once, and we solved it once and it worked. So next time we encounter that problem, of course, we're going to solve it the same way. Anti-patterns are like that, except not. So that is an extremely common and also wrong solution to a problem that repeats. So we have the same problem all the time, and we solved it once in a wrong way, so now we're going to solve it again in that wrong way. Seemed like a good idea. But it backfired. So the difference between a pattern and an anti-pattern is not only in the execution, but what happens after. Whether we actually have a solution, or after a while we have to do extra work in order to support the solution. And a lot of the times for anti-patterns are defined as solution looking for a problem. Yeah. So overall, those are parts of the lesson learned in software development, because to be honest, software development world moves extra quickly, but the knowledge kind of lags behind. So sometimes we have to do the same mistake 2, 3, 5 times in order to say that this might not be a good idea. Yeah. So one thing that we should note also is that anti-patterns are not a universal thing. They are not always an anti-pattern. You might have a special use case that is in which that anti-pattern is actually a pattern, where you can actually use it to solve things. But that's where the problem is. Because if you used it to solve one specific use case, and then try to apply that same solution to a zillion other different use cases, and you try to ram them into that solution, that's where it becomes an anti-pattern. So they are always kind of context sensitive. And what I want to emphasize, that anti-patterns are not errors. Errors are things that are always wrong. That I can say, you shouldn't have done that. In any case. Anti-patterns always require a lot of context. You shouldn't have done that in this case because of that, that, and that. So, that's it. I will talk a bit about my favorite software anti-patterns, not only in REST APIs, but overall. Because we have anti-patterns everywhere in software development. First of all, in requirement analysis, we have the analysis paralysis anti-pattern. So that means that sometimes we have some requirement that changes every 3 months, and we spend 4 months analyzing it. So as soon as we are finished with our analysis, we got to pack it up and throw it away, because we have changed the requirements. So we cannot get to the actual building of the software because all of our time is spent analyzing it. We have the golden hammer. That's usually a project design problem, where if we have just a hammer, then suddenly every problem looks like a nail. And we just keep using it. So we had success using, I don't know, Angular and Node.js on a project, and we're going to use Angular and Node.js on all of our projects, whether that makes sense or not. Yeah, reinventing the square wheel. Reinventing the wheel is when we just don't want to use a library because we can do it better ourselves. That library is no good. We don't want to use third-party dependencies. It doesn't have enough maintainers and whatnot. So we're going to make our own version of a common library. And of course, since that's not our primary goal in life, we're going to make it worse. So instead of using Redux, I've seen people use their own version of Redux that's like Redux, only worse. And of course, they don't have any support for that. Now, you've all heard of spaghetti code, right? That's not an anti-pattern. Nobody ever started designing a system and said, we're going to have this file that's going to be the controller, and we're going to have it have something like 10,000 lines of code. No, nobody ever said that we're going to make spaghetti code. It always happened by itself. It's always an error. It's not something that was supposed to happen. On the other side, we can have lasagna code, which is an anti-pattern. That is, when you have an n-layer application, and then you need to add some features, and you make an n+1 layer application. There's always space for another level of indirection. And then you have lots and lots and lots of layers, and I've seen code that has something like 10 or 11 layers, and basically 9 of those layers are just taking the same data that the user gave us and passing it along, and passing it along, and passing it along, and passing it along. So if we want to add a Boolean or something like that to a field, we need to change a lot of files, and the only goal is just to change those files. Recent anti-pattern is something called ravioli code, which is basically if we have microservices and those are good, means that more microservices are better. And then we're going to have extremely tiny, lots and lots of extremely tiny services that basically need to coordinate with 10 other microservices in order to work. So that's the ravioli. Everything is isolated, but it doesn't make sense on its own. You still need the sauce. And from the management perspective, we have the mushroom management. What is the best way to manage developers? Just like mushrooms. Keep them in the dark and fed them manure. Or seagull management. You've kind of experienced, most of you experienced this when you have a manager that's too busy or just doesn't care, and it will do what a seagull does. It will swoop in occasionally, do its job, and go off. So once in a while. Those are some of my favorite anti-patterns that are not specifically connected to REST APIs. Anyway, so let's go back to the REST APIs, and I do want to emphasize that this talk is primarily opinion-based. Even if there were some facts until now, from now on, all of this is my opinion. It's a guess, but it's an educated guess, I would say. So, let's talk a bit first about errors in REST APIs. So, these are the things that are never a good idea. These are not anti-patterns. These are things that, if you have them, you should remove them because they're not good. So, first of all is ignoring HTTP methods. And this usually comes in two flavors: when you have a post to get some data, or a put to get some data, or you use a post to delete items, or alternatively, you have endpoints that are called create new item. You've seen that. And it doesn't matter if that is a post or a put or a get, it's still wrong. Yeah, you shouldn't do that. Yeah. We have status codes, fun with status code, because you should know which status code means, and you should use them. There is just no reason, if a method errors out, to return a 200 OK with an error message inside. Anybody seen that in production? Yep, that's an error. Inconsistent naming. If we have one part of the system that uses a table and an apple and a pear, we should not have another part of the system that uses tables and apples and pears, because what does that make the user? It makes the user angry because he never knows whether he should put an S at the end. And that's the mildest version. We can have lots and lots of cases when we have errors like this. One other common error is that the designer of the API doesn't really care about the UI, and they have no idea what the data volume will be. So one side of the coin is that we're going to have sorting and filtering and whatnot on all of the API methods, and we have an endpoint that will return up to 5 items. For example, the continents of the world. Do we need sorting on that? Do we need filtering on that? Do we need paging on that? Not really, it's 7 items. Yeah, we might discover a new continent, then it will be 8, but it will never be 100. Yeah, until global warming screws everything up, but then the list of your problems is your API needs paging. And we have the other, more common side of the coin, when we just, the developer said, well, this table works, we have an endpoint that returns the data, and then it goes to production, and that table has 20 million records, and then we transfer a gigabyte of data to the client. And the client shows 3 items. Yeah, we've all done that. So, and the last that I wanted to talk about was having no documentation, because if we are able to use the API, everybody should. We have the source code, it's going to be on GitHub, who cares about documentation? No, that's a major thing, because APIs should never be designed to be used by the same person from the back and the forth. So we need API documentation. We need to explain how these things should be used. So, yeah, some of the examples are something like this. We have get on books.id. This is the beta API. So, but we post on book. Why? Because we are creating a single book. And now the user will need to remember that they need to do that. And of course, the update can be done like this. It's still a post. And the error will be, of course, be at 200. And we will have deleting books. Why not have it this way? Yeah. Have you seen code like this in general? Yeah, I have. Yep. We're going to delete. It doesn't matter if it's delete book or book/delete, if it's a post request, and it will return 200. Anyway, it's not a good design. Yep. So there are plenty of things that can go wrong with an API, but the biggest one is this one. Even if you are doing everything wrong, at least do it consistently. Because then the user can basically have some expectations of how your API works. So it's bad if an API returns 200 OK for error messages. But it's worse if it has 10 endpoints, 7 of which return 200 OK. And 4 do 400s and things like that. So the worst API error is in being inconsistent. Sure, try to be consistent in a good way. But if you cannot do that, then be inconsistent in a bad way. There's a, sorry?
I think people heard me, but it's anti-pattern when it's called job security, when you are the only person that can make the SDK for this API.
As long as it doesn't get so unmaintainable that the project is going to get scraped. Yeah. Yeah, on the other hand, on the last season of Breaking Bad, if you remember, Jesse was quite essential to an operation, but he was still living in a hole in the ground. So, yeah, there's a YouTube video made by Dylan Beatty. I don't think I can play it now, the sound doesn't work. but try to find it after the talk. Your API is a Hall of Shame that basically explains how to make beta APIs. So, oh, it actually started playing. I think it, yeah, first. We're going with a commercial. Anyway, let's go to the anti-patterns part of this talk. So we have a few that I have identified. I gave them some fancy names. You can see that, yeah, we're IT guys, we like naming things. So we have the chatty catty, we have the kitchen sink, front-end fusion fallacy, the CRUD obsession, the Russian doll scheme, the sticky server situation, and the header neglect defect. And I will delve a bit deeper into all of these. First of all, so these are anti-patterns. And a lot of the time you will say, well, isn't this opposite of what you said 5 minutes ago? Yes, it is, because it's up to you to determine whether you have the specific use case that you need. So what is the chatty catty? If we have way too many endpoints, sometimes we have a composite object that has a lot of properties that we'll need to load. We have a person, and that person has an address, that person has a banking account information, that person has preferences, that person has additional details and whatnot. And if we have an endpoint for getting all of them, and we are showing a user profile. So that means that our front-end code will need to basically call 5, 6, 7 APIs in succession in order to build one object that it needs to display. So we will have to do multiple requests for a single use case. It will increase the network traffic time, it will increase the server load, and it will sometimes dramatically increase the time that's needed on the front end to actually process and manage all of that. And moreover, if it's done in a non-obvious way, you might have a situation when the front end will need to do a lot of processing in order to extract the data that it actually needs. So, yeah, most of my examples will be about a library, so you can understand what the relationship are. So we have an author, and then we have the author's nationality, and we have a specific endpoint for that. We have the books for the author. We have a specific endpoint for that. And of course, on the author details page, we're not going to show all the books for the authors. We're going to show some. But that's left over for the front end. We will have series written by the authors and things like that. So now, if we want to show an author somewhere in our application, we might need to do multiple requests. And moreover, on many places when we do need to show an author, we're going to need to have those multiple requests. By the way, I won't be showing how to solve this, because to be honest, if you detect this and you want to solve it, the solutions are usually trivial. And there's just no one-size-fits-all. So that's the chatty catty. And of course, we're going to have a lot of versioning headaches, because if we have a lot of endpoints, this means that all of them can get versioned independently. So we will change a part of our application, and we will have 3 of those 5 endpoints that needs to change. And then the front end will change one of them, won't work, they will change another, it won't work, they will call us, we will say, oh, we changed the 3rd one, and so on and so forth. So it's a maintenance nightmare. On the other hand, we have the kitchen sink problem. This is when we have APIs that basically return everything. So you have one API and you ask for a piece of data. You might just need an author name somewhere, and it's going to tell you everything about that author. It's going to give you a full object, basically half the database, and it's going to transfer it to you because you said, I want this author. On the other hand, that's kind of a one-size-fits-all approach. So you mentioned that you need an author. Here is your author. Doesn't matter what you need about it. And of course, that's going to be a performance impact, because we are doing a lot of processing to compile that data on the server. We are wasting a lot of network traffic to transfer that data. And the client will just cherry pick, I needed this of that data. And this way, this is additionally a fun game for your security people to play, because they will need to verify all the requests that are there not overexposing data, that you are not sharing data that you're not supposed to show, and then just not display it in the front end. This is a very common attack vector that people will just do F12, inspect the responses and say, oh, they gave me the password here. It's not going to be a password, it's going to be some token or some other PII. But it's very easy to overshare data this way. Because what you're doing from the server, you're saying, here's everything, take your pick. It's like GraphQL without the GraphQL. Yeah. So if that is a use case that you want to do, you can always use GraphQL. So it will be something like this. We have books, return all the books, authors, return all the authors. If we want to have an author, we are automatically plugging everything, doing a huge database query that will get all the data. Maybe the series are not static data, maybe they are calculated. And then, whether the user wants it or not, we are returning everything related to the author. It doesn't matter whether the user wanted to display author details or they just needed an author name. Sorry? Somewhere in the middle, depending on your specific use case. Yeah, there was another question. Yes, these two anti-patterns are kind of opposite of each other.
Can we actually make API that is used as a layer to transform the data to not overexpose? For example, an endpoint that uses a combination of different endpoints just on one endpoint, for example, I guess. Maybe we don't have the code of the API.
Yeah, that's one approach. Another approach that I kind of prefer is to have some kind of a filter object where the client can basically say, I want the author, but I want the author in a basic variant, or I want the author, but I want author, nationality, and books, things like that.
Maybe filtering out in the backend, I guess.
Yeah, then on the backend. I'm not talking about how we're going to do that, how we're going to actually process that API call. It's relatively obvious and straightforward, but just a lot of the time you can detect this just from reading the endpoint names. Yeah, another that is kind of connected to these two, and it's in a orthogonal kind of, is the front-end fusion fallacy. And I've seen this over and over again, is that we're going to design an API that's customly built for our specific front-end, for the current specific version of the front-end. Because if we have a page that shows those pieces of data, we will define an endpoint that returns the specific data for that page, and only for that page. Which means if you're not that page, that data is unusable for you. And it might mix different sets of data. It might show the borrowed book. If you're having an author overview, you might have the author details, and the sidebar has borrowed books. So in the author details response, you also get a list of borrowed books. Why? Because that specific front-end needs it. So we are tying our backend to our front-end. We have one call for one page, and that basically makes our server stateful in the way that our server has to mirror the front end. The front end, if the front end changes, our backend needs to change. It's unusable for other clients, so that API cannot be given to a third party and said, okay, we have the data, just use it, make your own application. And it's unusable by our front end, because the front-end guys will say, okay, we have a great idea, we're doing a complete redesign. And you're going, I guess I'm going to have to throw this server away and rewrite it. Yeah. So that usually looks like this. We have a dashboard when we have authors, series, whatnots, and we have the author profile when we return everything for that page. Frontend has it easy. They just get the data and map it to the frontend. Everything works. But this is data that is not related to one piece of data is not really related to another. So we are tying our frontend to our backend. That said, a very common and useful pattern that is used right now is using BFFs, backend for frontend. So we have a separate backend that only serves that specific frontend. That is okay. But in that case, we know that that backend and that frontend are a single unit. We are not pretending that they are separate. We are not pretending that they are different. And if you do this in your BFF and have a separate API server that is actually used by the BFF, that's fine. But if this is your main API design, your main output, then it's an anti-pattern. Yeah. On the other hand, so we have one way when it's ultra specifically tied to the front end, and I've also seen this when we have the CRUD obsessions, which means that if we have 5 tables in the database, we have exactly 20 API endpoints. We can 25 actually, because we have get for the authors, we have get by ID for the authors, we have create an author, we have update an author, and we have delete an author. And the same for the books, the same for the nationalities, the same for everything. And if you have a banking system, what does that mean? If you want to have a transaction from one guy to another, then your frontend will need to call the accounts table for the first guy. It will need to call the accounts table for the second guy. It will need to update the amount for the first guy. It will need to update the amount for the second guy. And congratulations, you just rediscovered transactions. So you will have to write all the logic, business logic in your application in your frontend, because the backend is just basically, you can, in that case, and I've seen this kind of APIs, why not give the client basically an SQL editor? Yeah, because the backend is just that. It's an SQL editor with some kind of authorization and authentication layered on top of that. And you need to put in a login, and once you put in your login, here is an SQL editor. It's just as simple to call those APIs as it is to write SQL queries. Of course, that means that the frontend will have to orchestrate everything. Yeah, the backend is easy to build and easy to test. We can have 100% test coverage on the backend because it does nothing. It's totally tied to the database structure, which means adding a new table is just generating a few endpoints. And of course, each time we change anything in the database, that means we have to change a lot of things in the API and most importantly in the front end. Sometimes this is useful for some tables, but not all of the time and not for all of the tables. I don't even need to show this because it's going to be straightforward. Yeah, we have this post, this post, those are the methods, and we have them replicated as many times as we need. And I kind of always end up here, whether I want it or not, the Russian-Chandler scheme. That is when we have an object that has a relationship with another object, that has a relationship with a third object, and so on and so forth, because we do have those parent-child relationship in our overall architecture. Those happen, and that is not a problem. But if we have to specify each and every part of those relationships all the time, we are kind of going in this direction, because our URL structure will get longer and longer and longer and longer. For example, if you have to access a book, we have to say whose book we are accessing. So our endpoint will be something like /author/ID/book/book ID. Do we need that? And it kind of always becomes a bit of a meta language because the user needs to program a URL. You cannot just write that URL because that URL is overly complicated. And the problem, another problem is we have no idea what the ownership is. How do we check if that URL is correct? Because that URL contains something like 7 IDs. It has all the data that it has about that object. And then we kind of get lost. It's hard to do it on the front end, it's hard to use it on the front end, and it's hard to use it on the back end. Something like this. If you have a library, we're going to specify all of these keys. It's okay if you have composite keys, but you don't have to separate them this way. So that author, that book, that chapter, that page, that paragraph, why? Why do I need to specify the whole, basically, provenance of a thing in order just to get a single thing? Can I just use its ID? Yet another thing that always happens, in a sense, okay, not always, but a lot of the time, is that I said the benefit of REST should be that we have a stateless server. And but it's kind of nice and easy to save some data on the server. It's always there. So we can always save some temporary state on the server. This means that it's easier to work on the front end sometimes because the server remembers this. The front end doesn't need to have some kind of a session part. If the user is having some sort of huge grid, we will remember that he's on page 2, so when he asks for the next page, we will give him the 3rd page. And when he asks for the next page, we will give him the 4th page. But then the server has to remember the current page. And we are losing idempotency, because we are issuing a GET request, we are getting the 3rd page. We are issuing a GET request, we are getting the 4th page. We are issuing a GET request, it fails. We are issuing another GET request, we're getting the 6th page. That is a thing that will happen. And we are getting basically the worst of both worlds, because we have a stateless server which has state. So we're not getting the best of both approaches, we're usually getting the worst of both. So this happens over and over again. It's okay if you store a session state or something like that, but I don't like that as well. You can use JSON Web Tokens or things like that. But it's easy to get into this trick when you have your server orchestrate your front end. Your front end requests a few things, and the server knows always to return the correct thing unless it doesn't. So we have some code like something like this. And one thing that is somewhere between, so this is the last one, and I will open the floor for questions then. And this is somewhere between an error and an anti-pattern, and it's a thing that everybody does, is that a lot of people forget that one huge part of the HTTP protocol and of the REST protocol is headers. And they don't treat the headers as part of the request. So we're going to put a lot of data inside the body, a lot of data inside the URLs, but not use specific headers that were sometimes even designed for that purpose. For example, if you want your data, if your data response can vary, JSON or XML, there is a header for that. And always I see that people say, oh, you just need to append question mark format equals XML in your header, in your URL. You have a header for that. And it's quite easy to do that. Don't forget, making an API testable via the browser address bar, that's not the goal. Yeah, it will need to be tested by some kind of a API testing tool, like Postman or something like that. So if the only thing, because you are doing something, is in order to be able to test it from the browser bar, you're not doing it wrong, correctly. So also another thing, who here has V1 or V2 in their URLs? Everybody. There is an HTTP header for that. Of course there is. I'm not even talking, yeah, that was the content type headers. There are plenty of content policy type headers when we can restrict usages to the relevant applications, when we can manage course instead of using allow origin star. And we can also add custom headers. And they're extremely powerful. If we want to specify that this user has some extra possibilities or extra requirements or something like that, or maybe if we want to use filtering via the headers, we can also do that. So a lot of people are not, would rather mangle their body with unneeded data or add a zillion query string parameters instead of using headers. And a lot of the times, headers are totally easy to use. So, yeah. Okay, this is not a good example. So, those are some of the anti-patterns that I've seen, that I felt. And just as a conclusion, what's the time? How much time do we have? Oh. We're going to go out early for the beer. That was my goal, by the way. So, the bottom line is, think when you are designing your APIs. Never forget that that API will actually need to be used. Try to think a bit about a referent usage. Why is this API needed? Not just I need to create, I have this thing in the database, I need to expose it somehow. Think about how an application that uses this API will look, how it will behave, what it will need. Does this make sense from a usage perspective? Because all of this boils down to the same thing. We just don't care how this thing will be used. We should. We don't need to develop a complete front-end application just to test the API. Of course not. But we should have a vision of a referent usage. This API or this set of APIs solves this user story, this user case. So we're going to build the correct API. Yes, sometimes it will be a CRUD API because that's how that thing works. Sometimes it will be tied to the front end, somewhat. But it will be correct for your specific use case. If you need to use a BFF, use a BFF. Definitely have documentation, because in order for a front-end developer to actually use that API, they will need documentation. Whether they will use that documentation in the format of a Swagger file or some Notion page, or you personally, they will use the documentation. So unless you write the documentation, you are the documentation. So unless you enjoy spending time explaining for the 7th time that this header needs to be entered, write documentations. Again, there is no silver bullet. You will make mistakes, you will fail, but use each failure as a checklist for the next time. Because I messed up this time, and I will make sure that the next time I mess up, it's going to be in a new way and not in the exact same way. Do I have this case again? If I do have that case again, then don't do the same solution that didn't work, that bit me in the ass the first time. Sorry? Yeah, consistent from the API endpoint. Yeah, and of course, be consistent. So that's about everything that I had for this. Any other questions or comments or whatever? Sure.
I have two questions. First, a short one. I'm sure everyone has had to write endpoint that triggers a cron job or something that's manually trigger a cron job. What do you use for this? Even if it has to add data, change data, delete data, do you use a get or you try to use different HTTP method for that depending on what it's doing?
Well, does that cron job change something?
Sometimes yes, sometimes not.
So do you know what cron job you're triggering or not?
Yes.
Well, make it so that it's clear what it does. Because if you have two cron jobs and one is just extracting some data and returning some kind of report somewhere, that could be a get, that is okay. But it actually generates the report and saves it to a database by ID or something like that. Does that return or it just says triggered?
Let's say you have a cron job that synchronizes two databases, for example, and it takes data from one database and syncs to the other base, just part of it. Maybe it's getting too specific, so...
if you're waiting for a response, that's most likely a GET request, I would say, depending on exactly what the thing does.
Okay, never mind. So the second question is, have you used JSON API standard? What do you think of it?
JSON?
JSON API standard for building REST applications.
I don't think specifically. I think I've read it, something like that, but I had a feeling that it was too opinionated. Yeah, because it's a general solution to a specific problem. I don't think that it's gonna work. It will make all the APIs look the same, but not all business cases are the same. I would rather tie my API to the business case than to the technical specification. So I want, I'm not one of those guys that say never use any kind of verbiage ever in your URLs, because then you cannot change a status or you cannot do an action that is basically not a crude operation. Yeah, sometimes you will need to do that, but as long as it's clear, it's okay. That is my personal approach. That, and again, that is an opinion.
Do you have any anti-patterns or patterns for that matter that are related to caching? So is there something that we should create our API in such a way that it is more more well-designed to be cached by the client and get used of the HTTP?
I do have quite a few strong opinions on that, but they're mostly in the implementation details part. And I try to steer clear of that, just the API design. Because in general, however you do it, it's going to be, the implementation is going to very wildly. So, yeah, why not? I love usually output caching on GET requests, when you basically just cache the actual responses, and then you just echo them later for a certain period of time. But of course, cache invalidation is unsolvable, so you need to manage that then.
So, does GraphQL solve most of these issues?
No. GraphQL is great for some scenarios, but implementing GraphQL correctly is, I would say that it's a bit harder than REST, because I've seen many GraphQL implementations that are basically the crude obsession. Like, here is the data, you get a single endpoint, and in this endpoint you can query everything. So you're basically pushing the responsibility of querying to the client. Here's an SQL editor. Yeah. You say what data you want, you say how I want to aggregate it, you say how you want to group it, you say how you want to filter it. That's a SQL query.
I think related to the previous question, Maybe there are some REST API that is comparable to GraphQL, that they have so many little endpoint,
Yeah,
I guess.
yeah, definitely. It's very easy to make a bad REST API and a bad GraphQL. But in order to make a good one that is actually usable and fun to work with, you have to think about the business domain and you have to think about the user of that API. How I would like this API to look like. Yeah, you don't have to implement the complete front end, but at least have a vision of how this page will work. So it will have these things and the user will need this, this, and this, which means that I will give them these capabilities. And then the users will still use your API wrongly, but less.
So, thank you for the presentation, it was very good. I have one question, because you said that it's very important to have the correct HTTP verbs. So, what is your opinion is the correct usage of post, put, and patch? Because this is a...
Oh, that's an unsolved issue and unsolvable. So again, I will give you my opinion based on experience, based on a lot of things. So rule of thumb, it's gonna have billions of exceptions, but rule of thumb, post is only for creating new items. So if it's essentially creating new items and basic items, I mean, because of a lot of the time, when we update one thing, that essentially triggers a creation of some other thing. That's a side item or something like that. No, for that I wouldn't use post. But post means create a new basic item. Put is update in the sense of exchange. I have an item and I want to change the data of that item with this data. And if I want to do a partial update, depending on how partial it is. I love using patch for things like status changes and things like that. When I'm updating a part of the object, when I just want to alter it, but then I make sure that I don't have the full object in the body. If I'm patching a status, I'm just sending a status and an ID.
I just had an opinion to the question of the colleague here. So post, I assume, if you don't specify a field, it means that you're applying a default. Put means that no, you don't want that field changed. Now, if that conflicts the business logic, then you return error appropriately.
A 200 one. No, that's, yeah, I love using 422, which means semantic error, which means that I understood the data, but you're stupid. Yeah. There's just no correct way. That is one part of that where you should have consistency. What is put, what is post, what is patch within your API. Because however you do it, it's going to be different from half of the things that are out there. Because there are plenty of differing opinions and it's not a clear-cut thing. But whatever you do, pick one and stick with it across the application. Yeah. My preference is that post for creation, put for full update, patch for partial update. Okay, I think we ran out of questions. Thank you, it was a lovely discussion. I will still be here. Let's go have some beers.